Hello everybody. So today we are going to talk about electron configurations. So in your Edmodo, you want to go to the post that says electron configurations. Here's the link for the reading. Here are our practice questions, and here's my email that you can send your answers to. So let's take a look at electron configurations. So, electron configuration notation is when you're not using the boxes and arrows method. You're not using the orbital filling diagrams. So each occupied sublevel is going to be followed by a superscript that is going to be the number of electrons in that sublevel. All right, if you don't remember the whole sublevel and how many electrons it fits, go back and review Hund's rule. But for example, the hydrogen configuration, we only have the 1s orbital, and it has 1 electron in it, so 1s1. Helium is 1s2 because it has 2 electrons, and they're only occupying the 1s orbital. Okay, multiple occupied sublevels are going to be written one right after the other. The electron configuration of lithium, as we continue, that is 1s2, 2s1. All right, the sum of the superscripts in the electron configuration is going to be equal to the number of electrons in that atom. Okay, it's going to be equal to its atomic number. Now, atomic number, you remember, is the number of protons. Neutral atom, we are going to have an equal number of electrons and protons. So here they have a sample problem with the orbital filling diagrams and electron configurations. So it says, draw the orbital filling diagram for carbon and write its electron configuration. Okay, first thing you have to do in any problem solving is list what you know. So we look at the periodic table, we know that carbon has an atomic number of 6. All right, they use Z equals 6 from the nuclear notation. So use the order of fill diagram to draw an orbital filling diagram with a total of 6 electrons. Okay, so we know that its atomic number is 6. That's the number of protons. And we know that since it's neutral, it is going to have 6 electrons. All right, so we follow Hund's rule. So we fill each sublevel 1 electron at a time in each shell. So we have 1, 2. These automatically fill up with the 2. These fill up with the 2. And then for the 2p sublevel, what you want to do is put the electrons in with the same spin, which means the arrow is going to be pointing in the same direction, but you fill up each shell 1 at a time. You fill up each box 1 electron at a time. All right, so then its electron configuration gets to be 1s because we have 2 electrons in the 1s orbital, 2s2, so we have 2 electrons in the 2s orbital, and 2p2. So we have 2 electrons in the 2p orbital. All right. So as long as you know the order that the orbitals get filled and how many electrons go in each orbital, you should be fine. Okay. So when we get more into the periodic table, we're going to talk about the rows of the periodic table, which they call periods. Okay, So the first period, if you look at the periodic table, is only going to have hydrogen and helium. This is because the first principal energy level, so energy level 1, only consists of the S sublevel, and only 2 electrons are required in order to fill the whole principal energy level. So the principal energy level is if it's 1, 2, 3, 4, so on and so forth. Each time we get a new principal energy level, we start a new period on the periodic table. So once we get to 2, the principal level of 2, we have another row on the periodic table. When we get to the principal level of 3, we add yet another row. Okay. So here is the table that has the electron configuration of the second period elements. Because remember, we did the first one. We did hydrogen and helium. So now it's getting into the second period elements. So make sure you finish your questions, turn them into me.